Geometry is the mathematical study of shapes, geo meaning shape and metry meaning the study of. Since geometry takes a look at shapes and is usually a short break from different algebra courses, it also tends to be learned in a slightly different way from other math courses. Geometry is generally learned through more memorization-heavy learning tactics, as opposed to algebra where you tend to follow a structure or procedure while utilizing rules. Geometry is usually more about saying, hey, remember this thing? Since this thing is the case, we can conclude this particular attribute about the problem. Let's kick things off by talking about properties of shapes. Points are described as the locations on a coordinate system, usually represented by an x value, which is the amount moved to the right or left, and a y value, or the amount moved up and down. Edges are physical components of a space that connect 2 points. Sometimes in introductory geometry, edges are referred to as sides. But sides are not to be confused with faces, which are two-dimensional shapes constructed by interlocking a bunch of edges to make a particular shape inside. Angles are measurements measured in either degrees or radians, representing how far in different directions two edges are facing from their connecting point. Note that angles are not measured in distance, but in degrees or radians. What are radians? Well, good news, you don't have to worry about that until trigonometry. Bad news, some courses will decide to introduce it anyways. But to make a long story short, 180 degrees equals pi radians. 2 dimensions, or 2D, means that the shape can be held within the confines of two axes, usually represented by an x-axis and a y-axis. 3 dimensions, or 3D, means that the shape can be held within the confines of 3 axes, usually represented by an x-axis, a y-axis, and a z-axis. This also means that 2D shapes can be represented in 3D spaces, since the 3D space has a 2D space plus more. When working with formulas for shapes, which I will display on the screen now in quick succession, you can identify which shapes are 2D and which shapes are 3D based off of the amount of variables multiplied together. For example, let's take the perimeter and area of a circle. The perimeter of a circle is 2 pi r, while the area of a circle is pi r squared. Note that pi is not a variable. It's a constant number that's approximately equal to, but not exactly equal to, 3.14. It's also irrational, which means that we can never perfectly represent it numerically with the mathematical tools we currently have. So we just write the symbol pi. So back to these formulas. In the perimeter formula, we have 2 times pi times r, so r is the only variable being multiplied together here. If we compare that to the area formula for a circle, pi r squared just means r times r, which is 2 r's being multiplied together. Therefore, the perimeter of a circle is 1D, whereas the area of a circle is 2D. Speaking of shapes, a triangle has 3 edges, a quadrilateral has 4 edges, a pentagon has 5 edges, a hexagon has 6 edges, a septagon has 7 edges, an octagon has 8 edges, a nonagon has 9 edges, a decagon has 10 edges, and if your teacher asks about any more edges than 10, they're crazy. We talked about angles before, but let's talk about that a bit more. 2 line segments, or lines, can be parallel or perpendicular, or neither. Parallel means that they have the same slope and are facing the same direction. Perpendicular means that they are facing complete opposite directions and have both opposite and reciprocal slopes. So in geometry using angles, parallel lines are 180 degrees apart and perpendicular lines meet at a 90-degree angle. Note that if you were to rotate a line segment such that the angles between them are larger than 180 degrees, then looking at the angle from a different perspective can help you see that the shortest angle between them is less than 180 degrees. This means a few things, such as the sum of the degrees in a circle being 360 degrees, the sum of the interior angles of a triangle being 180 degrees, and the sum of the interior angles of a quadrilateral being 360 degrees. But most importantly, it means that the maximum angle that 2 lines can be apart from each other is 180 degrees. If it's between 90 and 180 degrees, it's known as an obtuse angle. If it's between 0 and 90 degrees, it's known as an acute angle. Let's talk about the Pythagorean theorem. This states that if you have a right triangle, that is, a triangle with a right angle or a 90-degree angle, and we label the longest side, which is opposite the right angle, as C, which of course stands for hypotenuse, and each of the legs as A and B, then we have that A squared plus B squared is equal to C squared. Therefore, if we have any 2 side lengths of a right triangle, we can find the remaining side by isolating the variable and taking the square root of both sides of the equation as necessary. Geometry will also briefly cover volumes, but again, those are mostly just formulas, so I'll just list them here. Maybe after taking calculus, you can understand why some of these are what they are, but in general, use the following rule. To get the volume of a strange shape that's been extruded with some height, take the area of the base shape, then multiply by the height. Let's talk a little about transformations. Transformations are ways that you can change an object or shape in a space. To anyone interested in game design and development, this segment is extremely important. A translation is a movement of an object, whether it's some amount to the right or left, some amount up or down, or some combination. A rotation is exactly what it sounds like, rotating an object some amount clockwise or counterclockwise by some amount of degrees or radians. A reflection is also exactly what it sounds like, reflecting an object about an axis. A dilation means to scale an object to be larger or smaller by some starting point, where everything in the shape either expands or contracts from that starting point. And finally, a skew, which isn't often discussed but is a type of transformation, describes how something gets squashed or stretched in one dimension while keeping its shape and size in other dimensions. And finally, let's talk about proofs. Proofs could easily get their own video all by themselves, so I'm just going to talk about the basics. The concept of a proof is that you're not trying to find an answer, but rather show that something is or is not the case. From the perspective of the average geometry learner, this means that you're given the answer and asked to explain why. However, critical writing skills that you would learn in an English course will not help here. No, instead you have to abide by the following rules. 1. You can only say mathematically accurate things. 2. You cannot assume any information unless it's either axiomatic, it's evident based upon a theorem, or you've already shown it to be true in the problem. 3. If you have a statement claiming something new, use a theorem or principle that explains it to be true. 4. When you reach the conclusion that the thing you were trying to prove is the case, then congratulations, you did it. Speaking of congratulations, you did it! You just learned geometry.